Welcome to Daily Math Concepts. What we're going to be looking at today is, we're still on January 2020. We're looking at question 1 all the way up to question 4. All right, so let's begin. So what we have here is a fraction of 4 1/5 times 1/3 minus 1 1/4. And so what I want to do quickly is just convert everything to improper fractions quickly. So we multiply the denominator times the whole number, and then we're going to add the numerator and keep the denominator. So 5 4 is 20 plus 1, that's 21 over 5. And then we have that times 1/3 minus 5, 4 ones 4 plus 1, 5. So we're getting 5 over 4. Again, what we're going to do though is that we're going to deal with the multiplication. So let's deal with that first. When you're multiplying, if there are things that could cancel, for example, 21 over 5 multiplied by 1/3, definitely we're seeing where we could cancel the 3 into itself one time and the 3 into the 21, 7. And this part would have left us with 7/17 over 5 times 1, that's 5. So therefore, the result for the multiplication is 7/5, and we want to subtract 5/4. So in doing so, the LCM though for the 5 and the 4 will be 20. So 5 into the 24 times, 4 times 7, that's 28. 4 into the 25 times, and 5 times 5 is 25. So our final answer is 28 minus 25, that is 3 over 20. And if you have gotten that, then you're good to go. All right, so there it is. There it is, we handled that part. The next question says, find the value of using a calculator, otherwise we're finding the value of this. So all we want to do is just to go ahead and let us say we write about 4.1 and then 1.25. We want to square the 1.25, and then we'll get minus 1.5625, and all of that is over 0.005. So quickly, I just want to find the value for the top, 4.1 minus 1.5625, and that becomes 2.5375. I want to divide that by 0.05. So I want to divide that by 0.005. And our answer is 507.5. All right, so here's our final answer right there. So basically, we just put everything on our calculator and we just walk the answers through, all right? So those parts are testing to see when you can compute using the calculator. All right, so this question says, a stadium currently has a seating capacity of 15,400 seats. All right, so we're dealing with 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied. So basically then 75% of the total. So 75% of the 15,400, that's what we're checking on. All right. So that becomes 75 over 100. We want to multiply that by 15,400. All right. So that's what we're really checking right now. So in doing so, we're getting, it's on your calculator, and we're looking at, all right, so this is actually 11,550 persons, all right, that are actually there, all right? Number of people, that amount of people that we actually have right now at that capacity. 11,550 people, that's all we have. All right, so the next question says, the stadium is renovated with a new seating capacity of 20,750. after the renovation. What will be the percentage increase in the number of seats? All right, firstly, in order to do that, we definitely have to think about what was the seating capacity before. It was 15,400. All right, so the percentage increase is simply the difference. So finding the increase then. So we want to know the increase, all right? So the increase was actually 20,790 minus 15,400. This will be the increase in the number of seats. All right, so let us quickly subtract that. We minus in 15,400. So the increase in the number of seats would have been 5,390. This is the increase in the number of seats. Then you want to write this as a percentage. So then it's going to be 5,390 over the original number of seats. And then you turn that into percentage, right? So that will take us to the answer. So 5,390. We want to divide that by 15,400. And then you multiply it by 100. And then we're getting 35%. All right, so that is taking us to 35%. Yep, there we go. 35%. The stadium is to be renovated with a new seating capacity. Oh, we just did that. Hold on. All right, I think I have an overlapping question. All right. All right, good. We just did that. All right. Oh, here's a question. It says a neon light flashes 5 times every 10 seconds. So 5 times every 10 seconds. So if you look at this, 5 times every 10 seconds, show that the light flashes, 43,200 times in one day. All right. Now, let's look at this. We could know a number of things. If it flashed 5 times, it flashes 5 times in 10 seconds. All right. All right. So then, say it's giving, if you check this out, it's giving, if we divide by 5, basically, it's giving 1 flash, yeah, in 2 seconds. This is the idea. Just 1 flash in 2 seconds, because so by the time it's 10 seconds, it gives 5. So we know that 1 flash in 2 seconds. Now, if I know the amount of seconds in a day, then I could just take this out. I just divide it by 2 and I get the number of flash. So what I want to find on the side here is the number of seconds in a day. This is giving us the number of seconds in that hour. And then you want to multiply that by how many hours that we have in the day. So you're looking at multiplying 60 times 60. So this is 1 hour. And then now, how many hours in the day? So you multiply this and you get the total seconds in one day. So this is giving us the total number of seconds in a day. So we just simply multiply that. So we're talking about 60 times 24. So this is landing us 86,400 seconds. All right, that is in one day. But we are suggesting now, if we have 86,400 seconds in one day, and then every 2 seconds the thing flashes, then we could divide it by 2, and it tells you how many flashes in that day. So it tells you that. So we're just confirming that. All right, in a day. The thing is, there are more than one ways you could work this out, but in the interest of time, that's just one way you can work it. So we'll just go. All right, let's grab the next question. All right. So here is our next question. So the next question says, factorize the following expressions completely. So we're actually looking at 5h squared minus 12hg. The common factor here is just h, because there's no number apart from 1 that can go into 5 and go into the 12. So it's h, open the bracket, h into 5h squared, we're going to be left with 5h, and h into 12hg, we're left with 12g. All right, so there it is. We have factorized that and collected our marks to move on. All right. Next question. 2x squared minus x minus 6. So quickly, this one, there's no common factor. It's not 4 terms to do grouping. It's not the difference of 2 squared. We're going to be using the AC method to factorize this quadratic expression. So let us take out A, which is 2, coefficient of x. B is the coefficient of, no, A is the coefficient of x squared, sorry. B is the coefficient of x, which is -1, and C, which is the coefficient, which is the constant, all right? Just the constant term. So AC is equal to 2 times -6, which is equal to -12. So then the factor pairs of -12 though are of 12. These are my factor pairs of 12. These are the factor pairs. It's one of these that would work. To get a 1, it's a 3 and a 4. All right. So we have a 3 and a 4. Whenever my AC is negative though, and I know that one of my factor pair would be positive, one would be negative. Then we're going to have to make sure that let the bigger one take any sign B has. So the bigger one is a 4, B is negative. So the 3 is positive, then the 4 is going to be the negative. These two numbers that we have come up with will actually take the middle term right there. So we'll have 2x squared plus 3x minus 4x minus 6. And so now we have a chance now to group these. So we're grouping group 1, group 2. So in dealing with our groups right there, let us take out x, which is the common factor for these first two here. So we have 2x plus 3, and then -2 is the common factor there. We'll have positive 2x and positive 3. And then whenever my two brackets like come back identical, like this bracket is exactly like that bracket, then I will refactorize by taking out these, yes. And then we could say put the other two things, but in factorizing, x comes down and -2. And so we're good like that. But there we go. That is our AC method factorization there. We would have collected some more marks. Going forward, we want to solve the equation here. In solving this equation, what we want to do is on the right side, we want to do some quick distribution. So I'm writing out my r plus 3. Then I'm going to distribute this 3 here to the r, and then I'm going to distribute it to the -5. So I'm getting 3r minus a 15 right there. Let's collect like terms. So I want to collect the r's on the right side. So it means that I'll subtract r from both sides. And then, so if I rewrite this, I have 3, which is equal to 2r minus 15. And then now I'll add 15 to both sides. As you could see, adding 15 to both sides. So I'll have 18 is equal to 2r. So I'm gathering my r's on one side, gathering the constants on the other side. Then I'm going to divide by 2, divide by 2. 9 is equal to r. So there we go. 9 is equal to r. And that's the answer for that. All right, so we have that done. Sorry. Okay, so we want to make, so let me push this to the side here. So I'll do it right there. So we want to make K the subject here. So I'm going to put this here. So I want to make K the subject right here. So I actually have 2a is equal to pi k squared plus 3t. And we want to make K the subject. So I'm going to leave the subject and anything directly attached to it for last. I'm going to leave these for last. So it means that I'm going to subtract 3t from both sides, right? So if I rewrite this, then I'm definitely going to have 2a minus 3t, and this is equal to pi k squared. Now, at this time, I'm going to be leaving the k squared for last. I'm going to get rid of the pi. The pi is actually multiplying, so I'm going to divide by pi, and I balance the equation by dividing by pi. So we could see the pi cancel itself. So at the end of the day, if I go further, I'm having, actually I'll have 2a minus 3t over pi, and this is equal to k squared. But definitely I need k, not k squared. So I'm going to have to take the square root of the right side, which means I'm going to have to square root of the left side as well. So a square and a square root will cancel. So I could write about the final answer here. So 2a minus 3t over pi, the square root of that is equal to k. So right there, that is my k right there. Question B says, question B says, yeah, getting myself a little bit comfortable right there. All right, question D says, a farmer plants 2 crops, potatoes and corn, 1/10 on 10 acres of a piece of land. No, let me read it over. A farmer plants 2 crops, potatoes and corn, on a 10-acre piece of land. The number of hectares of corn planted, let's see, must be at least twice the number of hectares of potato planted there, right? 2 inequalities to represent the scenario above. All right. So we're talking about, we're dealing with potatoes and corn. So on a 10 hectare, so we know the limits there, 10. So then we're saying that, you see, the number of corn, acres of corn, plus the number of acres of potato P must be less than or equal to 10, because it cannot go over 10 hectare. So that's one inequality there. What's the next inequality? They gave a scenario, the number of hectare of corn. So we're talking about corn, of hectares of corns planted must be at least. So if it is at least, it must be greater than or equal to 2 times. So it must be greater than or equal to 2 times P. Right? So that's the second inequalities or inequality there. So we picked up our 2 marks there, and that's that. All right. Number 3 says the diagram below shows a hexagonal prism. All right. So we have an hexagonal prism. Complete the following statement. The prism has dash faces, dash edges, and dash vertices. All right. So what we want to do is just to check them off quickly. So we want to just quickly check these off. So let's count them. Let me try to take out a marker to count. So you could count with me. Faces. Faces are the surfaces that you could rub your hand against. All right. So we're seeing a number of faces, but the faces though are linked to the faces are actually linked to these edges that you're seeing. So there's a face coming from here, going that way. There's a face here going that way. There's another face here going that way, all of that. And then now there is other ones on the opposite side. So there's a face here. So that's 4. There's another face here. That's 5. And there's one at the back here. That's 6. And then now outside of those rectangular faces, we have 6 rectangular faces. We have 2 hexagonal faces. This is one here at the front, all of this. This is another face, yeah. And then there's another one at the back here, all of that. So we actually have 8 faces overall. We have 6 rectangular faces and 2 hexagonal faces. So we have 8 faces overall if we check that out. In terms of edges now, when we talk about edge, you're talking about those edges is actually where 2 faces would have met. So an idea is this is an edge. So that's 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edges there. All right, and those are from those strips. And then outside of those 6 now, we have 6, 7, 8, 9, 10, 11, 12. Then we have 13, 14, 15, 16, 17, 18 edges. So overall, we find 18 edges, right? All right, very good. So we have 18 edges right there. Vertices now. The vertices are like the corner spots. So if you think about the corner spots, you're talking about the vertices. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 vertices right there. And that is how we just count them off quickly. 12 vertices and we are good. All right, 12 vertices and we're done. All right, so there it is. There we go. So the C question is it says a quadrilateral PQRS and its image P prime, Q prime, R prime, S prime are shown on the grid. So we're looking at it in this image. So object is a smaller one right now based on the question, and the bigger one is the image. It says write down the mathematical name for the quadrilateral PQRS. It's a trapezium. Some people call it a trapezoid. All right, so it is a trapezium. All right, so that quadrilateral is a trapezium. The next question says PQRS is mapped onto P prime, Q prime, R prime by an enlargement with a scale factor K about the center C, which is AB. Using the diagram above, determine the value of A and B, and the A and B here is going to be that center of the enlargement, and then K is the scale factor. All right, so let's find the quickly. We could just find the center of the enlargement quickly using a method. All right, so a quick method to find the center of the enlargement is that what you need to do is to connect any 2 corresponding points. For example, right again, right here. I want to join 2. So I'm connecting Q to Q prime, a very long line. All right, I could change the color for us, maybe a red. All right, good. So that's Q to Q prime. So we draw that line. And then whatever, I could just connect I could just connect R to R prime. Let me connect R to R prime. So from R to R prime right there, and I draw a very long line through it like that. All right, let me change the color again, maybe to another color, blue. All right, good. All right, so there it is that we I have drawn. So any 2 corresponding points that you connect, all right, just 2 corresponding points, where they meet is where the center is. That is a method of finding the center of enlargement when you're given the image and the object of a dilation, or what we call an enlargement. So I'm just going to highlight the fact that this is where they meet right there. So all I have to do is to put on my scales. So basically looking good. This is -1, this is -2, this is -3, so this is -4, -5. This is a 1, 2. So then it is where a -4 meets 1. That's right here. And that is my center. So as it relates to our A and our B, we're talking A is going to equal to a -4, and the B is equal to 1. All right, so that is my A and my B right there. In terms of my scale factor, the scale factor is very simply linking two corresponding sides could have done that. For example, let's count from P, let's count P prime, S prime, right? So if I'm counting P prime, S prime, I'm counting 1, 2, 3, 4, 5, 6 units. I'm getting 6 units along that side. So P prime, S prime over PS can give me my scale factor. Because if I divide the image by a corresponding object concept, I will get scale factor. So I'm talking, this is 6 over 1, 2. So 6 over 2, which is equal to 3. So my scale factor is 3. So the scale factor is 3 right now, right? Let's go. So scale factor 3. All right, so good. All right, scale factor is 3. Let me get these off, right? Good. So my scale factor. So I could write that, hey, my K, my scale factor is equal to 3, and A is equal to -4, B is equal to 1. So the coordinate was -4, 1, and that was the center. All right. So there it is. We have easily just brush that aside. All right, let's go. All right. So fourth question now. It's a function. It says the function f is defined as f of x is equal to 2x plus 7 all over 5. Find the value of f of 4 minus f of -4. So we're going to evaluate these one at a time. So we want to evaluate f of 4. So if f of x is equal to 2x plus 7 over 5, then we want to evaluate f of 4. F of 4 is 2 times 4 plus 7 over 5. And this is going to be 8 plus 7 over 5. And this is 15 over 5. And this is 3. So then I could just conclude that, hey, let's put this aside. F of 4 gives us 3. I need to find f of -4. So let's go for f of -4 right here. F of -4. This is going to be 2 times -4 plus 7 all over 5. This is -8 plus 7 all over 5. And we're talking about, this is -1 over 5. All right. Very good, very good. So -1 over 5. So this is equal to f of -4. I need to be adding these ideas. So remember now, f of -4 gives me a -1/5. So I could quickly put them right here. Let's put the response right here for the final response. Let me put it right here. Let us know, just look at this. We're thinking of adding these. This is 3 plus -1/5. Already this is saying 2 1/3. All right, 2 1/4. Because what we could do is to say, if we are adding these, you're adding these, you could say, why not just change the 3 with a denominator of 5? Okay, so it's 3 over 1. So if we could look at it quickly, 3 over 1 times 5 over 5. So that's going to give us 15 over 5. That is the same thing as 3. So if I have 15 over 5, and then we are subtracting 1/5, then I'm going to be left with 14 over 5. And 14 over 5 is the same time as 2 times and 4 over 5. So 14 over 5 is okay. Or you could say 2 and 4 over 5, the same thing. So if you come up with any one of those responses, it's the same thing. All right. So f of 4 plus f of -4 is 14 over 5, or 2 and 4/5. All right. Let's go. Right. So the next question says, hey, why not just let us calculate the value of x for which f of x is equal to 9. So let me get the f function. So the f function says, hey, f of x is equal to 2x plus 7 all over 5. That's the f of x. I want to know what x value that I could put here. Basically, I want to know what x values I could put there. When it's worked out, I get 9. So basically, in order to do that, all we have to do is to equate the function to 9. So we're going to equate the f function to 9. So we're going to say 2x plus 7 over 5. We're going to let this equal to 9, right? And then now we're going to solve for x. So in solving for x, we're going to multiply both sides by 5, multiply that side by 5. So that cancels that. So we're left with 2x plus 7, which is equal to 45. I'm going to subtract 7 from both sides as I go. So 2x is equal to about 38. This is about 38. And then I divide both sides by 2. So x is equal to 19. So in other words, this is saying if I plug 19 here and work out everything, I would have gotten 9 as the answer. All right, so x is equal to 19 in this regard. All right, let's go further. Hence or otherwise, determine the value of f of. So we're saying f of 19 give 9. That's what we're saying up there. Understand? F of 19 gives 9. So if f of 19 gives 9, then the inverse of 9 gives about 19. All right. So definitely the answer is 19. Hence, if I use hence, I'll just go backwards. So if I plug in 19 in my function and it gives me 9, then the inverse of 9 goes back to 19. So I could say to us that this answer is 19. But let us say that we don't get the understanding the inverse to say hence would give me that. Because hence would have meant that that answer that you just gave, use it now and give back an answer. Bam, 19. The otherwise now would have been to work out the inverse and plug in 9. So that's the answer is already 19. But what I'm going to do is to do the inverse just as an alternate route. So I'm saying this is an alternate method, right? So the alternate method is I'm working on the otherwise, right? So doing the otherwise, we need to find the inverse. So let's go for the inverse. So let us start. I'll start by saying y is equal to, so f of x is equal to, I'm saying y to start. So y is equal to 2x plus 7 over 5. All right, that's me letting f of x equal to y, such that I write it like that. Whenever we're doing an inverse, we're going to switch x and y. So this means that x is equal to 2y plus 7 over 5. And then now we transpose for the new y. So we're going to multiply both sides by 5. So we'll get 5x, which is equal to 2x plus 7 over 5. It cancels. You could see that canceling right there. So let me come over here. So I have 5x is equal to 2y plus 7, right? And then now I'll subtract 7 from both sides. So in subtracting 7 from both sides, I'll definitely have 5x minus 7 is equal to 2y. Then I'm going to divide by 2, divide by 2. So basically, y is equal to 5x minus 7 over 2, which means that the inverse of f of x is equal to 5x minus 7 over 2. I'm saying now, if we do subtract 19, if we substitute the 19 in the f function, the inverse of f, the 9 in the inverse of x, we should get the answer, which is 19. So let us work it out and you'll see. So we're talking about 5 times 9 minus 7 over 2. 5 9s, that's 45 minus 7 over 2. That is 38 over 2. That is 19. But you wouldn't want to do all of that for 1 mark, because this question was set up so that we understand that if I have f of x, if I plug in f of 19 in a function and it gives me 9, then the inverse of the 9 will go back to that 19. So that is why I suggested that the answer is 19. You pick up that 1 mark. You wouldn't want to do all of this just to get back the 1 mark. But if this is what you understand from it, then no problem. All right. All right, let's go. All right, so we are at this question now, and it says the graph below shows 2 straight lines, L1 and L2. L1 intercepts the x-axis, the x and the y-axis at 4, 0, and 0, 2, respectively. Okay. L2 intercept x and y-axis 1.5, 0, and 0, -2, respectively. So those are seen, they are visible, and we're seeing everything right there. All right. All right, good. All right. So let's see what the questions are. All right, let's see what the questions are. I could just put on some numbers here. So this is 1, this is 3, this is 5, this is -1, this is 1, this is 3, this is 5, this is -3, -5. You know, this is -1, -3. All right, so you're seeing those intercepts. There is one here, there's another one there, there's an intercept here, and there's an intercept there. So those are the 4 coordinates. Those are the 4 values we get are for the coordinates. Yeah. It says so we want to determine the equation of L1. All right, 3 marks, determine the equation of L1. All right, so L1 is this line. So L1 is this line that we have here. So L1 is this line. Let me mark it. This is line L1 that we're dealing with. All right, that line. All right, so we're dealing with that line right now. All right, good. From this, it's going to be a negative gradient. We can count the gradient. We can work out the gradient. So it's up to us how we want to do it. So let's work out the gradient. So we have 2 points. We have 0, 0, 2, and 4, 0. So let me just say we have 0, 2, and we have a 4, 0. The moment I have this is my y-intercept already. So if I just find the gradient, no, I'm good. So I could say x1, y1, x2, y2. And we know that the gradient m is equal to y2 minus y1 over x2 minus x1. So this is going to equal to 0 minus 2 over 4 minus 0. So I'm getting -2 over 4, which is -1/2. Right? So my slope is -1/2. And if you look, you could see your slope is -1/2. All right, so our slope is -1/2. So then the equation of L1, so L1 equation in the form y is equal to mx plus c. I definitely have my m, which is my gradient here, and my c is right here, because whenever you have that coordinate, but you're looking at it, it crossed the y-axis at 2. So you could see this is where it crossed the y-axis right there. So definitely L1, I could write the equation easily. So L1 is, hold on, L1 is y is equal to 1/2 x plus 2. We're done. All right, it's equal to 1/2 x plus 2. Let's see the next, is it 1? No? All right, L1. All right, so they're suggesting what is the gradient of the line L2, given that L1 and L2 are perpendicular. All right, so the gradient for L1, so I'll say L1's gradient is equal to -1/2. The relationship between 2 perpendicular lines is that one gradient is the negative reciprocal of the other, which means turn it upside down and change the sign. So L2's gradient is equal to +2 over 1, which is just +2. So as you could see, the reciprocal and changing the sign. So L2 gradient is 2 right there. So there it is. We are at the end. And thank you for watching the Elements Concept. Please like, subscribe, and drop a comment.